Alright, so in this problem, I have 9 to the power of x plus 12 to the power of x is equal to 16 to the power of x. So what I'm going to do is first start by dividing both sides by 9 to the power of x. So this means that I get 9 to the power of x over 9 to the power of x plus 12 to the power of x over 9 to the power of x is equal to 16 to the power of x over 9 to the power of x. Now, 9 to the power of x over 9 to the power of x, those two cancel out, and I get 1. So I have 1 plus 12 to the power of x over 9 to the power of x is equal to 16 to the power of x over 9 to the power of x. Now, from here, I can rewrite this as 12 over 9 to the power of x, and 16 to the power of x over 9 to the power of x, I can rewrite this as 16 over 9 to the power of x. Now 12 over 9, that simplifies to 4 over 3. And 16 over 9, that simplifies to 4 squared over 3 squared. Now 4 squared over 3 squared, that's the same thing as 4 over 3 squared. And now I have this to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 4 over 3 to the power of 2 to the power of x, I can rewrite that as 4 over 3 to the power of x to the power of 2. And now I'm going to let 4 over 3 to the power of x equal to the variable u. So if I substitute in u for 4 over 3 to the power of x, I get 1 plus u is equal to u squared. And now if I subtract u and 1 on both sides, these two cancel out, and I get u squared minus u minus 1 is equal to 0. Now, to solve this equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get u is equal to negative of negative 1 plus or minus the square root of b squared negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1. And this is equal to positive 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So we have u is equal to 1 plus or minus the square root of 5 over 2. Now, remember how we let 4 over 3 to the power of x equal to u. Well, this means that 4 over 3 to the power of x is equal to 1 plus or minus the square root of 5 over 2. Now, this gives me two equations. I get 4 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. And I get 4 over 3 to the power of x is equal to 1 minus the square root of 5 over 2. Now 1 minus the square root of 5, that's going to be a negative number. And notice how this is a positive number to some power. Well, you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation, and all that's left is this equation. So to solve this equation, what I'm going to do is start by taking the log on both sides. So I get log 4 over 3 to the power of x is equal to log 1 plus the square root of 5 over 2. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. In this case, I have log 4 over 3 to the power of x, and I can move x to the front. So I get x times log 4 over 3 is equal to log 1 plus the square root of 5 over 2. So now that x is a term, we can isolate it by dividing both sides by log 4 over 3. So when these two cancel out, and I get x is equal to log 1 plus the square root of 5 over 2 over log 4 over 3. And log 4 over 3, I can rewrite that as log 4 minus log 3. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 30. So I'm going to first start by rewriting 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 30. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of n and n. So in this case, I have 2 to the power of 3 to the power of x, and I'm going to switch the places of 3 and x. So I get 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 30. Now, I'm going to let the variable u equal 2 to the power of x. So now if I substitute in u for 2 to the power of x, I get u to the power of 3 plus u is equal to 30. And now I can subtract 30 on both sides. So then these two cancel out, and I get u to the power of 3 plus u minus 30 is equal to 0. Now we have an equation here, and we need to find what value of u makes this equation equal to 0. So what I'm going to do to start is rewrite 30 as negative 27 minus 3. And the reason I did this is because 27 is the same thing as 3 to the power of 3. Notice how we have something in the form u to the power of 3 plus u. We could think of u as 3 in this case. So 27 is the same thing as 3 to the power of 3, and we have this minus 3. Now I'm going to put this in the form u to the power of 3 minus 3 to the power of 3 plus u minus 3 is equal to 0. So now, if I put this in parentheses real quick, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this turns into u minus 3 times u squared plus 3u plus 9 plus u minus 3, which is equal to 0. And now, because both of these terms have a common factor of u minus 3, if I factor out u minus 3, I get u minus 3 times u squared plus 3u plus 9 plus 1 is equal to 0. And now from here, 9 plus 1 is 10, so I get u minus 3 times u squared plus 3u plus 10 is equal to 0. Now this gives me two equations. I get u minus 3 is equal to 0, and I get u squared plus 3u plus 10 is equal to 0. So u minus 3 equals 0. That's pretty easy to solve. All I have to do is add 3 on both sides, and I get u is equal to 3. Now remember how we let u equal to 2 to the power of x, meaning 2 to the power of x is equal to 3. And now to solve this, I'm going to start by taking the log on both sides, so I get log 2 to the power of x is equal to log 3. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So in this case, I have log 2 to the power of x, and I can move x to the front, so I get x times log 2 is equal to log 3. And now if I divide both sides by log 2, these two cancel out, and I get x is equal to log 3 over log 2. Now, log 3 is equal to 0.4771, and log 2 is equal to 0.301, meaning this is equal to x is equal to 1.539. Now, going back over here, we have u squared plus 3u plus 10 equals 0. And let's use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 3, and c is 10. So I get u is equal to negative 3 plus or minus the square root of b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. And this gets me negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times 10, which is 40, all over 2, which is equal to negative 3 plus or minus the square root of negative 31 over 2. Now, the square root of negative 31, that's a negative number, so that doesn't work, meaning my only solution is 1.539.